Hey all, let's prove fact 8. Suppose f is continuous on negative a to a. If f is even, then the integral from negative a to a of f of x dx equals 2 times the integral from 0 to a of f of x dx. We're going to use the fact that f is an even function to solve this. But first, we're going to split the integral. We're going to say that the integral from negative a to a of f of x dx, now this holds true with any function, right? This is just an integral property. We split the integral at 0, right? That makes sense, right? Because we're trying to get a final answer that has an integral from 0 to a. So maybe if you can tell where we're going with this, we're going to try to show that this integral right here equals this integral. That's going to be the goal. Okay. Now right here, I'm just going to put this on the side here. Let u equal negative x. So that also means that x equals negative u, right, when we substitute that in for x. Also, we know that du equals negative dx, and that also means that dx equals negative negative du. Okay. So with that in mind, we're going to get the integral from, now be a little careful here, we're plugging in negative a in for x, and then 0 in for x. So that's going to give us a to 0, right? Because negative a is a. 0 is still 0. And we're going to get f of negative u, right? Because negative u equals x, or x equals negative u. And instead of dx, we're going to write negative du. This integral stays exactly the same. And if we simplify this a little bit, which I'm going to do just because I'm running out of space here, this is the same thing as negative the integral from a to 0 of f of negative u du. And then this guy stays the same. Right? Now at this point, we're going to use the integral property that we've used before. We're going to flip the bounds, right? We don't care about the integral from a to 0. We care about the integral from 0 to a. Well, that means that we get rid of the negative sign. And maybe at this point, you can see where the evenness of f is going to come into play here. Because f of negative u is the same as f of u. Because f is even. Right? So f of negative u equals f of u. And then I think it's clear at this point that we're finished. Maybe I should actually move this guy. I move this guy over here. So I can put right here that we have our final answer. 2 times the integral from 0 to a of f of x dx. Because if you think about it, it doesn't matter what we're calling our variable. U, x, whatever. It's the same thing. So this is really just the same thing as this guy. They're the exact same thing. We're just calling it u in one case and x in the other. Okay, so that's how you do that one. The way that you prove part B is pretty similar, right? Except we're going to have to show that the integral from negative a to 0 is negative the integral from 0 to a. All right, so we're going to start off the same way, with that substitution again. Let's see if we can get all of this. And let's paste it right over here. Nice clean divide. Right? So at this point, if we do our substitution, and let's say we're going to get that, we've got the integral from, so I think once again it's going to be from a to 0 of f of negative u times negative du plus the integral from 0 to a, f of x dx, right? Same sort of thing as before, right? We're again going to do this. Because again, that's true. And again, this is true. Right? A lot of this is the same. But the difference here is that what is f of negative u, given that f is odd? It's going to be negative f of u. And again, whatever we call our variables, u, x at this point, it's the same thing because the expressions are the same and the bounds are the same, and this equals 0. Maybe I'll put that in red so you, oh no, we don't need to do that. Okay. All right. So that's how we get our final answers, right? That's how we've established those two identities. Now, a quick application of this is we can say, note that the function sine of x over x to the fourth plus x to the eighth is odd because sine of negative x divided by negative x to the fourth plus negative x to the eighth equals, well, sine happens to be odd. Sine of negative x equals negative sine of x. Meanwhile, the stuff on the bottom is exactly the same. It's undeterred, unaffected by that negative sign. So this function is odd. So by fact 8, part B, we have that the integral from negative 2 to 2 sine of x over x to the fourth plus x to the eighth dx equals 0. Right? Which is good because I'm not even sure how to integrate that. Thanks for watching.